The old man built. The old man built. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds.
Hello everyone, welcome. My name is Nathan, otherwise known as Old Man Builds. What's up, Bernie?
Hello, hello. We are joining in together for the first time from the lab.
Right on, brother. Oh, how's everything going, man?
It's been absolutely great. I appreciate your hospitality, your family's hospitality, and the dedication of work that you do, and being able to match my own. It's quite amazing.
Right on, brother. Yeah, I see all your videos, man, up in the mountains, hanging out, taking pictures of all the lakes around here.
Oh, yeah. And so I'm only sticking around for the beginning here because I'm about to go do another one. I'm taking his son out, getting him outside to get some sun, and we climbing the local hill, and yeah, gonna get some more shots up there.
Oh, right on, man. Yeah, you guys going over looking at Canyon Lake this time?
Oh, yeah. And we be plotting how to sneak into the good fishing spots behind the gated community.
There you go. Yeah, last time I went, man, they caught more trees than they did fish.
Well, I think maybe you'll be looking for them barracuda, or I guess maybe we'll be cougar hunting instead in that gated community. But I just need the access to the lake. That's all.
Cougar hunting, looking for some old ladies out there with some money, huh?
Hey, nice. I got to get my American citizenship, right?
Yeah, I guess that's one way. Peel back the layers for your onion. Got it. Oh, man. Oh, hey, we're about done with that Bedini motor, man. I got in the last couple parts in the last couple days. I've been working on doing the video for the RAV, and that's been taking the last couple days, but we'll be back on the Bedini tomorrow and finish it out this week.
Yeah, so I got to give this man here props because I've been watching him making the RAV video, and shout out to Sean Calderon, and just the amount of work. Nathan's literally done 3 days straight of editing, recording, filming, and making a real documentary. And I half joke, and I'm 100% serious. Hopefully this guy gets hired by Netflix for making documentaries by the time it's done. And you're going to want to see the RAV Plasma Fusion episode when it comes out, because my God, has Nathan put a lot of work into it.
Yeah, well, we made the music for it, for the compilation. I kind of put that out there a little bit so everybody can listen to it. And then we also put, Joe made some background music for the whole video, and put it in real lightly behind everything. We got a lot of Sean explaining things and how it started. And then, you know, I'm in there a little bit, and you get to see me inside in front of my printers and stuff like that, and kind of in front of my area, you know what I mean? It's all cleaned up and stuff. So, yeah, I think the cutaways came out really good. And then I used some bunch of little tricks and stuff to put in a little more editing for zoom in and stuff. And then not make everything so plain, make sure there's always motion on the screen. So, yeah, it should come out good.
I am literally amazed, and I'm picking up so many editing skills from Nathan. I'm going to be studying every little trick that he has, because Well, it's just the quality. Like I'm so impressed, and so will all of you when you see it when it comes out. And yeah, we're about to finish that Bandini, and then tomorrow, and then I'll be heading up to Steve's place at Tesla Tech there for a few days or something, and we'll be joining you live on Friday. You'll be in the shop presenting Traveling Fools, and I'll join you from the test range, and hopefully we'll make something blow up. But if not this week, it'll be the next. Because we playing with hydrogen and a star in a jar, so something's about to go boom.
Nice. What's up, Mike? I sent Mike an invite in case he wants to come on and say hi real quick, man. There you go, Mike. I sent you an email.
Nice. Yeah, it'd be good to have Mike on right now too, because of you're working on the Renegade pulse motor device, and shout out to Mike for making that, and use a little step-by-step tips if he has them. Either way, we'll pull her off, but good to see you, Mike.
Yeah, well, we got the Renegade, and we also have the end machine that he built. So both of those are on the list, man. I got most of the parts for the end machine in already. We're waiting on one more part. So
yeah, and we got to study Aaron McCammy's model, as well as he's made a few additions to it. And then there's an additional wiring way of how you wire the solenoid cross back, and it does like a double pulse back essentially to the end machine. Quite interesting, but I won't do justice explaining it. So I'll get the video clip ready for next time so we can actually watch it together.
yeah, well, that'd be cool, man. All I know is we're filling capacitors, and doesn't matter which device you use, they're all a little bit different, but they all just fill capacitors, man. And we're just trying to get done as fast as possible so that we can use the energy. And if it's all amps, man, just have to shorten it down. You know what I mean? Add a coil in there. Maybe it'll strip some of the amps, put more voltage in there, and then it'll be able to level it so it goes way faster. Oh,
Hey.
what's up, Mike?
Hey.
Digging out, man. Digging out from the storm.
Yeah, we saw your video, man.
Yeah, I didn't see that. I'm gonna have to watch. Hey, we in palm trees down here, California.
Yeah, and we got 60 centimeters overnight.
Oh snap!
Yeah, you guys are buried.
Yeah, it's crazy. And now it's getting cold. So they're saying minus 15 tonight.
I don't miss Canada at all. I love America.
You should see this guy, Mike. He's up on mountains every day and here enjoying the sun, man. Out in the backyard, just hanging out, water and everything.
I guess that's why he's acting goofy, all the thin air when you go up in higher elevation.
Hey, yeah. What can I say? That's why I get high. I get high off the thin air on high elevations, and I'm just a goofy old bird of the Alchemist, but it's what it is, and I'm gonna get back to climbing that mountain. So I'm gonna move Mike up here, and I love you all, and I'll join in back live once we're from the top of the mountain. So how about that? All
Sounds
right.
good.
Much love.
Gonna go climb the mountain with my son. Take my son out there and go to the top of these things, man. Nice.
Yeah, I climbed a few in my day.
But it gets tiring, doesn't it? You get old, man.
Yeah. Well, I climbed a volcano when I was in the Philippines, so I can have that little notch on my belt.
Did you look over the side to the lava?
Yeah,
or?
Yeah. Well, it was all full of water, but it was a vent, and then that volcano actually blew up. I think about 6 years ago, it blew up. It's called the Taal volcano, Taal volcano, and in the Philippines, it blew up about 5 years ago. So where we were standing, looking inside the volcano, it was obliterated. It's gone.
Yeah, no longer there. Yeah.
Yeah.
Oh man.
So
you get your own movie, Mike versus the volcano.
Yeah. Well, I climbed that thing in 2009 when I was there. So it was quite a while ago.
Oh wow.
So, and when I was walking up the mountain, I could see, well, the ground was obviously getting a lot hotter as we were getting up higher. And Some areas that the tour guide said to us, don't stand there, your shoes are going to melt. Oh yeah, so I had to watch where I stepped in certain areas, right? And then also the gas too. There was some gas being released from the volcano, so we had to be careful about that because some of those gases can be deadly.
Oh yeah.
Yeah.
Yeah, it's like Yellowstone. You never know what to do,
Mhm.
man. Stay on the path.
Yeah,
Yeah.
exactly. But it was a good experience. Yeah, it was really cool.
Right on,
Incredible,
man.
like incredible part of the world. Like the vegetation there, everything's just so green, like so alive.
Yeah.
And being on the mountain, you know the soil, you could see it's really dark black, very
Uh-huh.
rich in minerals and stuff. So like to grow anything on that land is like a sure thing. Like it's gonna
So
grow like
is it like
crazy.
volcano ash that gets in there and they're mixing with the
Yeah,
soil?
exactly. You know, the magma and all that stuff comes out over time, and all those minerals are being spewed out from the inside of the earth, and basically fertilizes the entire area with rich minerals, and just makes it very fertile land, right?
Hmm.
So, yeah, it's a pretty incredible place.
A lot different than my house, man. It's all a bunch of dirt and there's a few bushes out now because it rained a couple times. You know what I
Well,
mean?
you're more, isn't your area more like borderline desert kind of thing?
Yeah, kind of. Well, there's
Yeah.
if you go over the hills, then there's the
Right.
beach, right? But
Okay.
in the valley, it's mostly, yeah, like you said, shrubs and, you know what I mean? Desert kind of thing.
Yeah. Yeah. Do you have a lot of poisonous snakes out in that area, like rattlesnakes and
There's rattlesnakes out there, yeah. You
yeah,
gotta watch out for them. But
yeah?
they
Better
don't,
tell Bernie.
yeah,
Three
I'm sure.
mountains, 3 mountains in 3 days, and I've seen one snake, and it scared the hell out of there because it's winter.
Got one snake. Oh, man. Some of these places you can actually go out and hunt the rattlesnakes. Friends that went out there and did that.
Oh yeah,
Yeah, I just told them I didn't want to go that day, dude. There's no reason to go do that.
yeah. We actually, even in Ontario, we have a rattlesnake. It's not seen too often. They're pretty elusive. We call it the Mississauga rattler. So we do have a rattlesnake that actually lives in this climate. So they go deep below the ground during the winter months, right? So, but they're not seen very often. But they're out there.
Yeah. Well, thankfully, we're surrounded by a bunch of communities. So they are there. There's just not very many. But once you get outside of this area and go over to like the wine country area,
Yeah,
then you start seeing them everywhere.
yeah, yeah. Because they have a lot more prey out there. Like we have wine country that's near Niagara Falls, on the way to Niagara Falls. We call it Niagara on the lake. So all up in that area there, it's all vineyards, right? So yeah, get a lot of snakes and stuff like that out there. Yeah, it was actually a very important area. Niagara on the lake was a very important area in Canadian history. So you can look
Oh,
that.
really? What they do over there?
That's when the U.S. invaded Canada.
It must have been like early times in like U.S.
Oh
history.
yeah, it was 18. No, it was 1812. I think it was. I have to look it up the date. It was early 1800s. There was a battle there.
Yeah, why would we invade Canada?
Yeah, yeah, you guys did. Yeah, you were trying to take over Fort York. Yeah,
It's like saying we're going to go invade Russia. Like all the cold there, why would you even bother?
yeah, yeah,
I mean, we're not going to freeze.
yeah. Well, I know like the U.S. forces, they come into Canada quite often for training,
Yeah.
to learn how to train in the cold climate. I have a few friends that were Canadian military, and they would see regiments from the U.S. come up and train with the Canadians in the sub-zero temperatures. So we were the best teachers in that because we know how to fight in that kind of a climate, right?
Well, yeah, you wake up and it's what, -20, -10 out there.
Yeah, yeah. Like this weekend coming up, they're saying this Saturday it might hit -24. So that's a little chilly.
Yeah, I'd
Little
say.
chilly for my liking.
let me put it this way, Mike. It was what was it, like 30 degrees outside, and I'm thinking it's freezing. You're probably thinking it's a summer day. That's
30 degrees to me is nice, like perfect. Like right there at the 30-degree mark is my perfect. Yeah, that's what
yeah.
I
We're
like. But
we're looking at the roofs like starting to freeze over a little bit at night, stuff like that, and I'm thinking, man, it's cold outside.
yeah, but
Usually it's
here it's the wind chill, right? It's when the wind comes off Lake Ontario. That's when it really hurts. Like it's so cold it hurts. So
yeah, no, thank you.
yeah.
Yeah, see, I don't even walk in the cold aisle too many times, man. That stuff, if you got screws in your body, they hurt. You know what I mean? They start
Any
throbbing and stuff in the
arthritis or
cold.
yeah, if you got arthritis or rheumatoid or whatever, oh, yeah, you're in a world of pain.
Yeah. Mike, check it
But,
out. I did your Renegade. Did you see the pictures of it?
yeah, I seen a couple. Maybe show me again here.
Yeah. I don't know if I have them right here, but I did.
I like the wheel, how you did the wheel and everything. That's cool.
Oh yeah. I did the wheel.
Now, I noticed you're using metal bearings. The ideal bearings for this one would be ceramic bearings.
yeah,
Because,
I wanted to start somewhere where I found
yeah.
all the flaws at first
Oh, okay.
and then fixed them. Like, for instance, you saw my coil, right? And you saw all the rods in there, and automatically you told me not to do it.
Mhm.
Yeah. And I did it anyway because I wanted to see why, you know what I mean? Because I don't work with pulse motors, you know that.
Yeah.
I want to judge reactions and be able to tell people, what I'm seeing and stuff like that.
Yeah, if your magnets are really strong that go around the wheel, they'll actually start cogging up the bearing itself, and it'll actually slow the wheel down faster. So you want that as free. Okay, that's good. Yeah, your coil there with the rods. Yep. Yep, that's
Yeah.
cool.
Well, last time you said to insulate the rods. Remember, tape every one of
Yeah,
them.
you should. Yeah, you should insulate them because what's going to happen if you don't have them insulated from each other, you're going to, when it's doing the back spike, you're going to get a lot of eddy currents going in there, and that could cause potential heating of the coil.
Gotcha. And then we lose the effect, right?
Yeah, yeah. So that's kind of a critical area. So
That's good. Well, I say that's good. That's good because then I can show it on film and, you know what I mean? Put the temperature gauge right there and show that it's heating and then put the right coil in there. Because what I did is I made a 3D core for this thing at a PLA where the individual ones go in and slide in.
Okay.
So that there's spacing in between them. Yeah, automatically.
Yeah, yeah. Cool.
So it's just it's a little easier way to do it, but it's a slide in, slide out deal.
Right.
So that's why I wanted to do it. Kind of some of the stuff like that. Same thing with the Bedini motor. You know what I mean? Overload some things, kind of do some things wrong, show how we fixed it, show why they're.
You could also you could also run it as an air core. There's nothing stopping you from doing an air core. You could also test that. I've never really been a big fan of air cores, but I have actually. Instead of putting a solid, those rods in there, what I did was I put a metal ball and I blocked off both ends. So when the back EMF spike happens, it shoots the ball back. And when it shoots it back far enough, it doesn't cog the wheel. It's like you see what I'm saying?
So it's like a spring effect.
Yeah.
It springs back every time.
Yeah. It go boom, 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 boom. You'll hear it pattering back and forth inside. I've done that and got some interesting results with that.
Huh. Well, I did follow your ideas about the bearings. So the birdshot, like stuff like that. I have a whole thing of that to put in there with some epoxy.
Epoxy. Yeah, that's perfect. And before you even put the those bird shots in, you have to insulate them so you don't get the eddy currents. So you have to spray them with a paint or something or a varnish or whatever, and make sure the balls actually have a coat of varnish on them. Let it dry thoroughly, and then put it in and make it form. Yeah.
That's so in case any one of them touches together,
That's right. Create an eddy current. Yeah. Yeah, because the idea with the birdshot, because birdshot has a very low iron or carbon content in it. If you get I think a number 7 birdshot, I think it was, has very little carbon in it, which they call it soft steel. It's actually very soft. Because of that, when the magnetic field collapses, usually in metals, especially like iron, it tends to hold the magnetic field for a few seconds after. You want that magnetic field to collapse right away, instantaneously. And that's what the number 7 birdshot does, because it has very low carbon in it. And it releases the magnetic field very fast.
Okay.
This is all from Paul Babcock in his motors. That's what he did. So
Nice.
he's tested it, and he says you get a really, really good coil. Probably the best core material you could use.
So let's see. So would you say throw like a little wafer in to divide them, like paint them, put them in there at like each layer?
Yeah, that's what Paul Babcock says. You could do like one layer, fill it with epoxy, and then after it dries a little bit, pour some more balls in there, and then a layer of epoxy on, and just do a layer by layer, layer by layer. Yeah, okay. And the epoxy will fill its way all through the balls and everything, and it'll just be one solid mass when you're done.
Nice.
Yeah,
that'd be good, man.
So that's your best bet. That's actually better than using the rods. But I haven't been able to find number 7 birdshot here. I have to actually have an FAC to buy it. It's a small arms fire license. So I can't even buy the ammo here. That's the problem.
Just get it at Walmart here.
Here I need a license. I need a FAC, small arms fire license. So man. The laws are different here. I can't even purchase the ammo. And it's just metal balls. That's all it is. There's actually nothing to, like, there's no gunpowder or anything. It's not even in a shell. It's just the balls. But even that, because it's classified as a firearm ammunition, I can't buy it.
Oh, that's terrible.
Yeah. Right. So that's why I haven't been able to do it.
Well,
so if anybody wants to donate me some number 7 birdshot and send it in a paper bag.
Send it in a paper bag. Isn't that illegal to send it over the border?
Yeah, maybe. I don't know. If it's just small brown balls, I don't know if they would even know what it is.
That's how I got through in a paper bag.
Bertie said he got through the paper bag. Bertie bought a bunch of stuff over, man, when he came down.
I bet. Yeah, it's cool. I like how you did that. Yeah, so those are the piezo's. Those are really good. So yeah. Solder. Put a good wire on it, a good gauge wire, and do a really good solder job. And then I hook mine up in series, so you put the 2 of them in series together, and then just straight. You could either put it on the positive side of the coil, or you could actually short it out. It doesn't matter. It works both ways.
I've done it on the negative side for the Tesla coil.
Yeah.
And that works out really well. It'll double. So I've seen that happen on the oscilloscope.
Mm-hmm. So you could even try shorting the coil out with the piezo's, or just put it on the positive or on the negative. You can try either or. It's going to work. Yeah.
Shout out Gigi in the chat there. Thank you for watching. Yeah, Mike, I was talking to Chat GPT, and they said that I need to choke before the capacitors. What do you think about that?
Before the capacitors, I've experimented with it, but you really want to see the way my Renegade works. It gets all its real power out of the transient spike.
Out of the high voltage spike.
Yeah, you really want a high voltage transient spike where the choke is going to kind of suppress that from happening.
Okay.
I have tried it before, but it kind of kills the effect, I find. You can experiment. You can try a lot of things with this. It just opens up the doors to so many different variations you can do. But the main thing is...
Sorry. Go ahead.
Is the spark gap switch. So you get the 12 volt automotive relay switch. You could probably pick it up at Princess Auto or whatever your auto supply shop. They'll probably have them.
That's what I was going to ask you because I've been looking for spark gaps. So you're
Yeah.
saying it's a relay switch?
Yeah, it's the automotive relay switch, 12 volt. I don't even know if I have one here. Probably everything's at my locker. Yeah, they're only about this big. They're tiny things, and go like Princess Auto or whatever, and it's just a single throw. It'll have 4 pins. 2 pins control the armature that go open and close, and the other 2, one will be straight across and one will be diagonal. That's your power. That's your power out. So
Does it look like a little contactor switch where the thing just taps back and forth?
that's
like
right. Exactly. That's exactly what it is. Yeah.
Okay. Now I know what to
Now,
look for. Gotcha.
Now, I like those particularly because when you look at it on the armature, it has a round carbon pad that's really good, and it can take a real beating. It doesn't burn out quickly, so it lasts. It doesn't like burn out in like 2 hours kind of thing. It will last. They
Very
eventually
nice.
do wear out, yes, but it all depends how you set up your back spike. The ideal thing is to try to get that spark down to like very minimal, but the bluish green color. When you got that bluish green color, you know you got the radiant spike.
Okay, bluish green, yes.
Yeah, bluish greens. Yeah, that's your radiant spike. That's what you're looking for.
Now I got another question for you. The diodes. Do you use Shockey, or I have the one that you have in yours?
You can use the Shockey diodes. They will let a little bit of back spike into the coil. I just use regular, what is it? The N, what is it?
2007 or 4007?
Yeah. Either one of those work fine.
Okay.
And then you got your full weight bridge rectifier there. Yep, that's good. And then you can hook it up to a step up transformer from there. Make sure it's a isolation transformer.
Okay.
And if it's an isolation transformer, you'll get a better effect. And then when it comes out of the other end of the isolation transformer, put it through the bridge rectifier, and then you can fill up caps. And what I do is I get I think it's the one I have is 60 volts and it's 12,000 microfarad. It's those big blue ones. You see them a lot in TV sets and that. Get one of those, and then when you dump the power into it, make sure you have like an LED hooked up to it, so it will build up and build up and build up, and then when it reaches 0 resistance, it will dump into the light, and the light will go boom, it'll flash.
Okay.
So it's almost like an automatic dumping circuit. You can get dumping circuits, but if you just want to see that effect, it's
So
very
do you
good.
dump
And
it into further caps beyond the light there then?
yeah, whatever you want. Yeah. Like in the initial like setup of the Renegade, before it goes to the isolation transformer, there is a light. That
Okay.
light has to be there. It's a ballast, so you don't overload the system. So when that starts blinking, you know it's working, and then you feed off both ends, positive and negative, to your isolation transformer. And then on the other end, that's where you put your bridge rectifiers. So
Okay.
I like to go bridge rectifier, capacitor, bridge rectifier, and to whatever load you wish. And you can kind of go from there.
So what is the load? Does it have to be anything special, or just put like a little motor out there, or
A
anything?
motor, a light, whatever you wish. Pretty much sky's the limit. The reason why I go from the isolation transformer, I go rectifier, capacitor, rectifier. I'm trying to smooth out that signal. So actually, after that, you can take that power coming off that capacitor and put it right back into your battery that's running the Renegade,
Okay.
and it won't short out because you've changed
Nice.
the symmetry of the signal.
I wanted to put it on a trigger switch with a to control the frequency, and then I wanted to control the duty cycle
Yeah,
afterwards.
you could do that too. Yeah. As soon as you rectify it, put it through a decent sized capacitor and rectify it one more time, sky's the limit. You can do whatever you want with that.
And at that point, it'll be DC or AC?
DC. It's
It'll be
DC,
DC?
straight DC. Yeah.
Perfect.
Yeah.
Oh,
And
man.
if you want to loop it back into the motor, you can do so because you've changed the symmetry through those two bridge rectifiers in the capacitor. It changes the signal completely. The motor doesn't even recognize the power.
Really?
Yeah, it thinks it's a foreign power coming in. Because normally, if you were to go off the light from the initial setup, even like before you put it through an isolation transformer, if you try to loop it back to your battery, it'll short the whole thing out. It'll die. It'll cog right up and heat up your wires and heat up your battery and everything. Yeah.
Oh, really? I didn't know that.
Yep. Yeah. You cannot directly loop that motor back into itself. It will blow up. and on the hold on one second.
Yeah.
Yeah, just give me 1 sec here.
Oh, man, we're learning everything today.
Yeah, sorry about that. My daughter was going a little crazy with her video game and hooting and hollering. Yeah, she had a PA day today, and I had a snow day, and my wife worked from home. And
Well, yeah, considering you had to dig yourself out, that's good.
yeah, it took me well over an hour to dig both cars out.
Wow. Yeah, see, I wanted to do these two in tandem, this and the SG, because I figure there's going to be like some cross learning that you guys are way ahead of me on. You know what I mean? And some tricks that I'm going to pick up.
Yeah, you start with the Bandini first. Honestly, you start with that, get that running good, understand it, and then the Renegades just kind of like totally. I don't know if you would say similar, but it's kind of I made a right hand turn kind of thing.
Well, I figured you did.
But
that's what
worked.
I wanted to see.
But the real thing that you'll find really interesting when you get this motor tuned really good, you could put, say, 48, 50, 60 volts into it, but it will take like microwatts to run it. Like your current, if you put a amp meter on your battery terminal going to the Renegade, it'll be down to like 20 milliamps, 30 milliamps, if that. Sometimes it'll even go lower. That's the interesting thing about mine. Where the Bandini motor, he even Bandini said before he died, he goes, if your SG goes over 100 milliamps draw, he says it's not right. There's something wrong. It should draw less than 100 milliamps off the battery.
I saw that. He did a video on that. I saw he was working with the SG, and he was also talking about alum batteries along with it. I watched that one. Yeah, I just watched it recently to wind the coil. I had to find, well, not to wind the coil, but to do the circuitry, because there's not a lot of clear pictures of what he did to make it accurate to what he did. You know what I mean? That was one of the only ones I can get up close to it and see it.
Yeah.
So that's what I had to do to make all my panels look right. Because it didn't look right at all without it, Mike. It was a jumble of wires, just a mess.
Yeah, it can get difficult. Winding coils is not my favorite thing to do.
Yeah, here I'll show you. This is what the circuitry came out to look like.
Yeah, I've seen that. Yeah, it looks really good. Now the thing is with those. So when you're running the motor, this is what I do know about this motor. If those neon lights start flashing, that means it's not tuned right. You got back spike going into the system, so you have to draw more off it. You have to tune that motor so those neon bulbs are not lighting up.
You don't want them lit up. I thought the whole idea was to light them up.
No, not those. No, those are the ones you don't want lit up.
Oh, that's interesting. I didn't know that.
Yeah. That's where a lot of people don't know. If they're lit up, you haven't got it tuned right. When you tune it just right, all those lights should go off.
Okay.
And then it's working properly. Then you can charge batteries properly.
Okay, so not over 100 milliamps. The
Yep.
lights have to stay off. So 2 rules I gotta learn doing this.
Like if you disconnect the battery that you're charging, those lights will turn on.
Okay.
Right? That protects your system from overloading and blowing your MOSFET. That's basically because they take 90 volts to run those lights. So you know the backspike coming in is pretty harsh. That you can fry a lot of MOSFETs with that. And he says in the beginning he did fry a lot.
the box of shame every one of us has.
Yep, that's right.
So I got a question then. Because I don't deal with these lights a whole bunch. Is it mainly the voltage that
It's a voltage
you're looking
spike,
at?
Yeah.
Okay.
There's not much current going through it, but if there is current going through it, you're gonna have the MOSFETs light up like a Roman candle, and you get the box ready.
Well, that's always fun.
Yeah. So the Bendini, you gotta be careful, especially with the MOSFETs. Always have some spares.
Well, they said to buy them in sets, so I bought a full set. You know what I mean? All the same package. So
yeah, don't like mix and match.
Yeah. So you give me a couple extras in there. So hopefully, if a couple of them burn out, it's okay. But yeah, it was a pain to do that wiring. I'll tell you that right now.
Yeah, no doubt. But the wiring for my Renegade, way easier. Oh my God, so much easier. But use good wire on it.
What are you thinking? Like 14 or 16, somewhere in there?
Yeah, 14 to 16 gauge is fine for wiring. Yeah.
Nice. Okay. Yeah, I think I even run 18 on my Tesla coils because they don't heat up.
And use the wire connectors too. Don't just like, kind of thing. Do a proper, wire.
No, I always solder them and put the insulation on them. I hate crimping things. It pisses me off. I never crimp them hard enough, and they always fly out. And at some point, they just tend to piss me off.
Yeah, soldering is always the best.
Yeah,
it'll be cool when you get it running. I'm really interested to see how it works for you.
Yeah, the only pieces I have to do, Mike, is on the sides of this thing. He had those connectors that you put on the front right here, and I had the wires. But in order to get the PLA to look right, I couldn't put them there. I had to put them on the sides.
Okay.
Not really that big of a deal, you know what I mean? But that'll have the solid connections with all the stuff that I can plug into and hook onto, like he did. But I guess that was more of a choice of mine to make it look a little different, you know what I mean? But keeping the same overall look. So
it's you got to personalize it a little bit yourself, right? Your own little, ingenuity and style and whatever. Put your trademark on it, whatever.
You know how that goes. You got to put your label on a little bit.
That's right. That's why I came up with actually my wife was the one who came up with the logo for my Faraday research. So
oh, nice. Yeah, I was looking at this thing, Mike, and I go, I had to do the motor part, right, where the magnets go. And then I had to make a separate top piece because of the amount of PLA to fill in the bottom and everything was just outrageous. Right. So I flipped it upside down, built the whole bottom, and then just glued the top on. Okay. Yeah. And then it's super thin. It's like 1 millimeter thick, you know what I mean, going around. No, yeah, 1 millimeter up. And then I used pins. So I have paint pens. And you basically can run the paint pen on there, and it'll paint the color that you want on there. That's how I got the silver.
Oh, yeah.
It's so much easier.
Yeah. It really helps when you got a 3D printer. You can really customize your wheels. And like I went as far as, cutting a few wheels with a water jet. So I was using aluminum 6061 and water jet everything, and then the hole size for the bearing, I was able to dial it in to the point where I just had to press it in, and it was like a press fit. It was perfect.
Oh, nice.
Yeah,
Yeah, usually on these, it's like a little rubber mallet, and you kind of just tap them in just a hair, just so they
yeah.
stay
I
tight
got
in the
I got
PLA.
mine dialed in so good. I was literally I just had to push it in with my thumb. Yeah,
Nice.
and it fit perfectly. So yeah, having access to a water jet helps sometimes.
Yeah, I'd say, man,
Yeah,
having access to an old wheel is even better. Let me just tell you this. These new wheels come with these rods inside. It's probably been that way for the last 20 years, and I don't know it. They used to be like a thick 1/2 inch rod that goes to the whole thing, or maybe a little
right.
smaller than that, 3/8. But
Yeah,
it used to go through the whole thing, and then if you wanted to switch it out, you could just get an all thread and switch it out, right? Not a big deal. But
yeah,
now they have these little parts in there. The rod is like super thin. Okay, it's like
yeah.
I don't
Cheaping
know,
out. Yeah,
yeah, like 3/16 thick, and you're like, are you kidding
yeah,
me? And they
yeah.
have these little lockers on the both sides. So I'm trying to
Right.
find an aluminum rim, and all I have is this new style. And I'm like frustrated, going, oh my god, dude, this is insane. I'm
Yeah,
just gonna have to put a metal rod to this thing. I can't get around it. You know what I mean? Luckily, the
yeah,
bearings and the one I got are just awesome, but
yeah.
it was
Yes,
frustrating.
I find some of the older bearings work amazing because they're so free running.
Mm-hmm.
And the closest thing that I can find right now that work as good as the old bearings are the ceramic. They have a
Ceramics.
very little, yeah. They're a little pricey, but they're totally worth it, and you don't have to worry about cogging or anything of the wheel. Because if you got really strong magnets around it, it's going to get attracted to those
Oh,
magnetic fields, right?
yeah, I was thinking
And
about that.
yeah, it'll actually seize up the balls inside the bearing, and then it'll actually slow your wheel down. Yeah. You
That's
won't
gonna
have
be
the
fun.
problem. Say you had a 12-inch wheel, you wouldn't have an issue. But when you have a wheel that's maybe 4 or 5 inches, yeah, you might have an issue because that field is going to bombard into the bearings in the
Oh,
center.
so I did. I think it was 8 inches.
8 inches, you might be okay.
Yeah,
Yeah,
like
you might still
50/50
have a
shot.
trace. You might still have a trace there, but it won't be strong. But if it was say under say 5 inches, yeah, it would definitely be an issue.
Yeah, see, I remember the last one. I was trying to do your other build that you did, um, and I couldn't get the damn magnets to work with me to do what you did. You tapped them like this.
Oh
Uh,
right.
yeah, so I'm over here doing it, messing with these things. Mike, I messed with it 3 days. I'm trying to get this thing to straighten out. You know what I mean? And just get on the edge of the magnets. There's no way.
Yeah, yeah,
No way unless you pulse it. This is just not possible. So yeah, I learned from that one, that magnetic field, how far out it goes, and exactly,
yeah.
every distance of everything. And it doesn't even matter. Like on one side, you don't even have to have a magnet. You just have to have a piece of iron.
Do you have the EM meter, electromagnetic meter?
Yes.
Okay, so when you start up the Renegade, when you get it up to high speed, go with that meter and see how far away you can pick up the flux from the magnets.
Oh.
You might be surprised. So as it spins, it's throwing that flux out like a sprinkler, right? And you
Mm-hmm.
could get pretty. With mine, I was able to get almost 12 inches away. Yeah, yeah. Sorry about that. I'll have to
It's
call my
okay.
parents
I
back.
did that with bar magnets. I had 1/2 inch by 1/2 inch by 2 inches, four of them running on a motor at 7,000 RPM. And the drop off was at 4 inches, then at 6 inches, and then it did get out to 12 inches, right? But
Yeah,
it was very minimal out there. It's like, oh, I mean, you couldn't feel the magnetics, but you got in like within a 1/2 inch of this thing. Oh my
yeah,
God, dude, there was nothing surviving that. Like as
yeah.
soon as it gets near it, I sucked in one of the coils that I built. It
Oh,
was,
yeah.
it tore it right out of the wood and sucked it right into it.
Oh, I bet I've done that a few times. I cut the coil uh, broke out of the way and then hit the wheel, and it's like, oh God, no, no.
I learned to put in the wood insets from the bottom. You know what I mean?
Yeah,
Instead of the
that's what it's.
top. That
That's
way
when I
it sucks
started
into the
3D
wood.
printing coil holders. I started 3D printing coil holders after that last time it happened. I said, screw this. I got to make a proper holder for it. Zip tie, strap it in place. And yeah.
I saw that. You
Yeah.
know what? I got a lot of work to do on that one and then the end machine that you had because I
Yeah,
bought
that one's, yeah.
I bought 2 of the magnets, but at 4-inch. So
Ooh, be
yeah,
very, very, very careful with those things.
yeah,
Do
they seem
not
like
get them
monsters.
close. They are, and they will break your fingers. So when
Oh.
you're putting them on the shaft, you be very careful. Like you're going to be squeezing them together, so you're going to be north poles facing out, south going in. But I would have a metal spacer on the rod that you're using, so about say maybe about 1.5 inches apart, and then you got to wrench them on and then screw them into place. So you have to do one first and then put the second one on, and you have to wrench it down, push it down hard, and then screw it down into place and hold it. Yeah, it could be a little difficult, but you got to be careful they don't flip over and then clap together,
Oh.
because the ones
see, I
I
was-
had were like 700 pounds lifting capacity or something. They're yeah,
I was gonna
potentially dangerous.
put the shaft on it and then build a piece of PLA for locking so that they
No,
stay.
the PLA won't hold.
It won't hold it? Oh,
No. No,
all right.
no, you have to use metal or brass. If you can get brass, even better.
What if I stick wood in between them as a divider? when I set
You
'em
could
up?
do that. You could do that. Yeah, yeah, would work. But like as far as screwing them in place to lock them in, yeah, either brass or stainless steel nuts. Yeah, because I put it on a threaded rod, right? That was the only
Mhm.
way I could push them together as much as I could. But my device got about 25 to 30 amps when I spun it up.
I saw that.
But 80 to 100 millivolts, that's about as much voltage you're going to get out of that, but huge amount of current.
Well, hold on. Did you? Okay, so you used 2 magnets, right? One on each
Yeah,
side.
2 of them squished together. Yeah.
Oh.
And I had 2 brushes, one brush on each side, and I had them on a spring so they could go in and out if there's some flex in there, right?
Okay.
And then especially on this setup, you have to use ceramic bearings. No ifs, no ands, or buts about it. Have to
then you
use
go order
ceramic
some.
bearings. Yeah.
Okay.
So
They sell those at Amazon, or do you have to get them
yeah,
special?
they do. Yeah, they're like $15 each Canadian, so it's like $10 US each, depending on what size you get. But yeah,
Oh, that's going to be an adventure.
that
Like,
that
these
one you
things are
got to be
huge.
careful.
They're like
Oh yeah,
this big. Yeah.
oh yeah, they're dangerous. I had them actually clamped together once on me. It took me 2.5 hours to separate them.
Did it really?
I kid you not. I had to slide them like this sideways.
Uh-huh.
So I'm on the floor on the rug and I'm pushing on the one magnet and I'm trying to like slide them. Oh my God. I thought I was going to break my hands doing it.
So I got a question for you then on these things. The magnets themselves have like a shell around them.
Right. Yeah. So
Okay.
those are the north. That's the ones you want facing out.
Okay.
Yeah.
And then
And
the open part.
yeah,
on
it just
the one
spins.
side.
Yeah, it just spins. Yeah.
Okay, but it's open, right? They're both open to each other. Is what I'm
Yeah.
saying.
Well, they'll have the field. You'll feel it when you're pushing them together. You'll feel it. But the contacts on the outer diameter are on the north side on the outside. So I have my north facing out. So they have like a little ridge that goes around the outer diameter. That's where my brushes fit.
You know what? Let me grab them real quick so you can see these. I just want to make sure because that brush alignment seems like it's going to be important. Give me 1 second. this up. Oh, these things are big.
Yeah, there you go.
So it's got
Oh, you
these.
don't have the hole through the center. Okay. All right.
Seems like you
And they
needed
have,
a moment. Oh, you already got it. My bad.
You're gonna you're gonna have to do yours a little different. You don't have the hole going right through it.
no, they didn't
That's
sell
okay,
them that
though.
way. They only sold them with the flat. It's the only one I saw on Amazon.
Oh, okay. So that's all right. That's cool. You'll have to do the bearings in the middle. Yeah. And then you'll have to come up with some way of spinning them, like on a belt or something.
Okay, I could do
Yeah.
that.
Like a belt drive kind of thing.
Huh. Yeah, they said these things. I mean, they have the one good side on here where I could take a
But that's a
threaded
good
piece.
diameter, though. I like the size of that. Yeah.
Yeah, so they have it's
Yeah.
threaded.
Yeah.
So, oh my god, these things are freaking heavy.
Yeah.
So yeah, the shaft goes on there. That's what I was asking because this has
Yeah,
a
so
shell,
you'll
so
have
they
to
would
get-
be.
Yeah. So you'll have to get a rod. Yeah, yours going to be more complicated because you're going to have a belt to spin it. Then you'll have the bearings on the shaft, and then magnets. I'll have to draw it up. Yeah, it'll be more like almost like a bicycle setup in a way.
Yeah, and so they're on each side of it. Yeah, on the
Yeah,
outside,
yeah.
not on the part where they. So that's why I was asking about the shell because the shell
Yeah.
cuts down the magnetism on the outside a little bit.
Yeah,
Probably not when it's
well, a
spinning.
little bit, but closer you can get them together, the better. Yeah.
Oh wow!
But
Plus, we
either
get it
way,
together
it's-
without snapping.
Either way, it's going to work. So, yeah.
If I got the wrong ones, Mike, let me know. I mean, I'll return them.
Yeah,
But-
let's see the face of it again. Yeah, those will work. Yeah,
Those will work.
yeah,
Nice.
Yeah.
Yeah, it's like 4.5 inches, something like that, something crazy. This thing.
yeah. Bigger diameter, the higher amperage you're going to get. So if you're spinning it at about 3,000 or 4,000 RPM, you should get it over 30 amps.
Oh, nice. Good,
Yeah.
good. I just wanted to see a result out of it. You know what I mean?
Yeah, it's
So-
pretty cool when you see it for the first time. And do it with an analog. Don't use a digital. Use an analog amp meter.
I bought one. I bought it
There
just
you
to
go.
put on the board with it so they could show it at all times.
Yeah. Use the analog.
Nice.
Does it have the shunt built in the amp meter? It'll say on the box.
it has
if
it
it's got a
outside.
shunt.
Yeah, there's outside. There's this little thing that goes like this, and it has two different spots. to hook
Right,
into.
that's your shunt. Yeah,
Yeah.
that's what you want. Yeah,
Yeah, I got that.
The
I got
shunt
the
button.
analog because I see everybody use the analog on that one.
yeah. It's better to use it. It's more authentic.
Well, that's what I'm trying to do some accuracy to everything that I build. You know what I mean? About 80-90% is where I want to be. And then the
Yeah.
last, little bit I can switch in and out to play with.
Yeah.
So
Yeah, that's cool. It
yeah.
should work
I'm
just
excited
fine.
about those, Mike. I'm following your lead, man. I'm not asking for the prints. I'm just trying to look at what you're doing and find out, you know what I mean, from what I can see
Yeah.
where you're at to
That
see
one
how
took me
anybody
a
else
long
would
time
approach
to
it.
build. The end machine took me a while to build because I had to make all the 3D printed parts because those spinning magnets, you cannot have any other steel other than what's there. Otherwise, it starts cogging it down, especially
Even-
like the bearings and all that. The bearings have to be ceramic because those fishing magnets are powerful. They'll start pulling on anything
Oh wow.
and
So-
keep it away from your cell phone.
What about aluminum?
Aluminum's perfect. That'll work with it. Yeah. Anything
work,
that's
okay.
not ferromagnetic, brass, aluminum, stainless steel, you could use. It's not ferromagnetic, so that's what you want. All the other hardware, non-ferromagnetic.
Okay. Because I was looking at instead of using the regular PLA, I was going to use PVC. You know what I mean?
Yeah, you
And
can use it.
get a harder surface at least because they're going to ink on everything.
Yep.
I figured there's going to be some torque in this bad boy.
Yeah,
You
there
know,
will be.
a lot of stress.
Yeah, and they're probably pretty heavy too, right? So they'll all be like spinning flywheels as well, right?
Oh yeah, yeah. No, they will. Yeah, these things aren't. Yeah, I don't know how to weigh them, but they a couple
How much
pounds.
did you how much did you get those magnets for?
They're $40 something a piece, like $48.
Yeah. Yeah.
Yeah.
They're
Well, I
pricey.
figured go big or go home on that one. That you know what I mean?
Yeah.
Because
Yeah.
if you got
Yeah,
around
this
30 amps, then I need to see if I can get a little, there
yeah, it's
better.
amazing that you get current just by spinning a magnet. Nothing else. Like you could have one magnet stationary and this magnet spinning, and you'll still get power. And you could get both magnets spinning at the same time in the same direction, and you still get current. Or you could spin one magnet one way and the other magnet the other way, you still get current. That's the Faraday paradox.
Oh, really?
That's called the Faraday paradox. So you can
Oh,
look that
okay.
up. You can read up on it. It's called Faraday's paradox.
I'm wondering this, Mike. If you run it through a Tesla coil side setup with an air core in it, it should reduce the amps, right? By bringing up the voltage.
I honestly, you would have to try it. I've hooked mine up to a plasma ball. I've hit it with 11 kilovolts. I've done all that. I've done some interesting stuff with that, and I got some interesting effects to that, which I really don't want to discuss online.
Oh, yeah, yeah. No, I saw the one that you did that's on your member section, man, where I saw the sparks, and I definitely want to try that.
Yeah, that was 11 kilovolts going through that sucker.
Oh wow. Yeah, definitely gonna have to try that one.
Yeah, and get some lasers, and yeah, I'll make a really good light show.
I never even thought about that. You just like
Yeah,
a
I
little cat
pointed
laser
lasers
work
at
or what?
mine. I had 4 laser pointers, and they're all facing at the spark gap itself on the spinning magnet. And the
Uh-huh.
spark gap, I was shining the laser right at the spark on 4 of them. So 2 on this side and 2 on the opposite side.
Nice. Yeah, see,
So,
I got a plan for that spark gap, Mike. I wanted to do your setup, right? And then I'm gonna pre-hit the cathode on it with a smaller piece of stainless, and I'm gonna preset it like I would a RAV. And I want to see if
yeah,
it'll
you
build
might be
one.
able to get the same effect.
That's what I'm hoping for.
Yeah.
So if it gives me the same effect, it should run a lot colder on the system.
Yeah.
So kind of looking forward to playing with this stuff, man. I haven't
Yeah.
had a chance to do any of it. I've been mostly on Tesla coils, you know that. So this is kind of a whole new thing for me.
Yeah. Anyways, I do have to jet. I just kind of came by and say hey.
Well, I appreciate it, Mike, dude. All the information I got today, man, you should totally hook me up, man. This is gonna be
All
awesome.
right. Awesome. All right, guys.
Right on, Mike.
Take care.
Have a good day.
Yeah, you too.
All right. Man, that's cool. Yeah, we got some cool stuff going on here, man. We're building. So we got our, you can see it behind me. My Bedini's about done. That one will be on the test block here this week. What I had already done, I was working on that video, like Bernie said. And then the other one, the pulse motor, you see where it is. There's only a few more things to hook up. It's like a day's worth of work once I get the PLA printouts done. And then you see the in machine stuff here. That one I haven't started yet, so I haven't even built the STLs. So good thing Mike came on and told us the information, man. I'm sure everybody out there probably knows it better than I do, but man, we're getting close, man. Three good builds in a row on this stuff, man. So that's really cool. And then the RAV stuff, man, is I took all the short videos and all the stuff that we did from the lives and stuff, and I put it in an awesome documentary format for Sean and everything that he does, and put a music video to it and everything. It looks really, really awesome, and I can't wait for everybody to see it. So we're going to do several videos on that as well. So as it progresses, I'll get better and better and better at doing all the detail work behind the scenes. So that's kind of something I've been lacking on. So I'm looking forward to that. So yeah, we're doing some good stuff, man. All excited about that. So hold on, I'm gonna pull up real quick. Dennis's work, as I know, I saw some shorts this week. He's been working with a bunch of stuff with the light, the same thing Sean was doing. So hang on just a second, guys. I'll pull it up. Here we go, Dennis. Look at that. I see the water down there. Let me see if I make it bigger. I did buy lead acid batteries, Johnny. That's the only ones I bought. Didn't buy anything else. Let's take a look at that again. You see, slow it down a little bit, it looks like. That's cool. Doing great work, Dennis. That looks just like when Sean did it in his. I even see, look, if you saw that, right, hold on. Let me pause it at the right time. Because I think you got right there. It looks like you formed a rav right on the side. You can see the bright spot right there. It looks like that you picked it up right then and there. That it immediately went to the glass. So did you have etching in the glass? The tube was thin. Yeah, it should have started to etch out right there on that glass. So that's really cool, man. Send an email to me. I got the email. Let me pull it up real quick. Yeah, you got the spot in there too. Let me download this so I can zoom it in. Okay, we'll go to downloads right there. Nice. Okay. And and of course it's not there. Let's see about an image file. There we go. Yeah, you can see it real good right there. I see a lot of bubbles from the water and stuff. Yeah, real bright on the side. Yeah, I'm going to learn a lot from those pulse motors guys. Usually I don't do that kind of stuff, so it's going to be an adventure for me. So I made sure I bought the right equipment for it. Let's see. The picture showed neat yellow nodes. Yes, it absolutely did, as well as the lower left. Yep, I could see. You see that Pontiac symbol that's down there? That you got the what looks like the flying bird from the Pontiac. I could see it right down bottom left on the glass. That looks like the Pontiac bird. You know what I mean? The Firebird, kind of like a phoenix. That's really cool. The green spot under it has a hole, huh? Nice. Yeah, you saw that one? Very good. That's awesome to see in there, man. Yeah, there's a lot of different information out there, guys. Just so you know, that's why I wanted to do the motors myself. So we'll see the results, and you can get the accuracy, from what to do, what not to do, and things like that, just by seeing, every mistake that I make. So upper right, I see the green in the upper right. Yes, I see it right there. It looks like what is it? 200? Is what it looks like you got right there, or like an OC is what the shape is. I see that. Yeah, Dennis is doing awesome on this. Let me go back to his channel and pull up the other one that he had there. He's actually got a piece of crystal too, so hang on. Yeah, look at that. Joe says that you got to get a hole started in there in order for it to break in. Yeah, you can see it starting to form the rav a little bit as it comes up closer to the crack line right there. You're definitely seeing the color change right there at the end. Oh, right there. See, it hit it and then it stopped. Let's see if we can't get that on the spot. Let's see. I can see it starting to want to form right there. Ooh, that's the right color. Come on. No. Yeah, you definitely got the right color going on. It goes from that nice looking purple to the gold look or the yellow. Trying to find the exact spot that I saw it at. Yeah, you can see everything changes as soon as you get to that color. Let's try to play it again. Nope. It looks like it didn't. It's trying to, but it doesn't look like it's curling as much as it needs to. It definitely got the right color in it. Ooh. Right there. Look at that. It's like an open core donut one right there. You see it? Man. It's close. Yeah. Really close, man. You got it right there. Like I said, Joe says when you go into these things, in order to get that whole thing to light up, you got to get a little bit of a hole in there. So, oh man, you know, society, man. Yeah, we shock rocks. Yeah, we do the other things, man. We make ravs, we make motors, everything else. Yeah, I build an anti-gravity device. All of it. You know, science is science, man. I love it. Yeah, you got it as a spiral, like right there. Let's see if I get a better picture of it so you can see what I'm looking at. Hopefully, it'll let me bring it up here. Come on, it's got to be like right here. There it is. Sorry, guys. Just give me a second. Got to find it again. Computer's acting up on me. There it is. There we go. Think of that. It's the only one I've ever seen a plasma donut not in a vacuum chamber. Congratulations on that, Dennis. Yep. Usually they do not form donuts. I went through this quite a bit, man. Yeah, look at that. That's amazing. First time I've ever seen it. Huh. The thinner quartz glows. I would imagine it would, with all the reflections of light you're getting into it. Absolutely. Huh. Dude, that's cool. There's no way around that. That's cool, man. I'll send you this picture back, Dennis. You'll like that one. Save that one. All right. Go back to the experiments here. Yeah, you can see it etched in the glass right there. Not a RAV? Is it just the wire against the glass? Is that why it's not moving around? Yeah, it looks like it. Dennis, I'd take a look at that picture because it looks like you got swirls going on in there. It's worth a slow, zoom in and slow motion that sucker. I don't think I'm going to be able to capture this one. Let's see. Right there it goes. Now it's moving. Okay, give me a second. You might have caught it. Yeah, there's definitely something in the glass. I don't know if you got a RAV on there or not, but you definitely got something in the glass. I could see it. So let's see. Where did I put it? Yeah, you see right under the bright spot. Check that area right there. It looks like you got the swirls in it. I can see the line right there. I can see the line there, and the one on the left side almost looks like a bull's head with a little dot in the center. Yeah, you definitely got some swirls going on in there. Huh. Oh yeah, you're burning through something. I'm gonna tell you that right now. The green effect shows the RAV was there. Yeah, I didn't zoom it in on that one. Yeah. Oh man, we'll have to go back to the video and look for the green dot in there. But yeah, you could definitely see the carvings in the glass. So we'll go back to the video file. Sorry. Yeah, the green dot's right there. I could see it. So if you look, what would it be? From the top down about 3 inches, 2.5 inches on the right-hand side, there's the little dot right there. You could see it, and you could see a little ring around it. Absolutely, you got it. So yeah, you created it. Yeah, it's right there, directly where it should be. Nice, brother. Yeah, you got it, man. That's cool. Yeah, definitely green light. You called it. Right on. We'll let this one play. Let's see when you see that light show up. Oh, it's got to restart. Let's see. Used to try teach actual engineering principles on here until everything I got regurgitated as mysticism. I don't think anything that we do on here is mysticism. I'm sorry if it came out that way. I know to be honest with you, it may sound something like that, but I never view anything like that. I know how sacred geometry works, and I know how you build it into systems and engineering. I don't think it's mysticism at all. I think it's just an engineering thing. I'm pretty much on your side on that one. There's no crazy stuff or woo stuff to me. It's all engineering. It just had to be proven out. So sorry if that's what's going on, man, but I'm definitely on your side on that one. Oh, there's the light. Just showed up. Yeah, you got it right there. Yeah. Why did the water smoke? Probably because you're breaking down the water itself. You get it bubbling. It should be releasing hydrogen right now. So you get a flame look in releasing the hydrogen right there. And of course, if you burn hydrogen, you get a little smoke. So yeah, that's what Sean got. Yeah, you got some micro bubbles going on. You got to remember to release hydrogen, all you need is ionization. So, like, even the purple right there does it. A fluorescent light bulb in water gives you ionization. You know, you got high voltage out there enough, you can get ionization. So, yeah, you're breaking it. Just like, Bernie does all these experiments here, and he puts 5 volts in there, and he gets all the bubbles to start. Some of them run on their own, man, and he's definitely getting hydrogen out of them. So, I would imagine that's why you would get that. Yeah, we were talking about this, I think, with Friday on Joe. Yeah, that's what I think you're getting. Just look at your water. It's boiling, right? But I don't think that's boiling. I think it's bubbling. I think you're separating, hydrogen and oxygen. Definitely taking your toll on that piece of glass, that's for sure. That thing cracked. Ooh. Yeah, you probably got it close to the side there. I'll say that. It snapped immediately. All right. Dennis, you got some cool experiments, my friend. Definitely getting there, with us on all this stuff, man. Definitely got it going on. Yeah, he's changing the color for sure. He changed the temperature of it. So I don't know how much everybody plays with high voltage, but I'll just put it out there because I'm sure you guys know, but everybody else might not know this. But as soon as you see the color change in there, it goes from that purple look and then it goes into that nice yellow sun looking stuff. You change the frequency on there and you change the temperature of it for sure. You brought up the temperature, you brought down the frequency, and it makes for a beautiful glow. So you'll see that in all kinds of experiments when you do that stuff. Let's see. You said, honestly, the shocking quartz thing came from Joe, and now other people are repeating it. Well, I'll be honest with you, man. They've been doing that. Oh my God. I saw Hutchinson do it, and I saw people do it for like 10 years on YouTube, and they never got the thing to light up. You've always, if you slowed them down, you always see the voltage go over top. Joe was one of the first times I've ever seen the actual thing light up from the inside, where he got it to reflect. You know what I mean? And activate it, and then it blew up. So, yeah, everybody's trying to shock quartz. I don't think a lot of people understand this about the quartz. It's basically a hall of mirrors, and you're not going to hit the hall of mirrors from the outside. That doesn't work. You got to hit the hall of mirrors from the inside. And once you hit it from the inside, that means if you got to take a Dremel and put a little hole in it, something like that, then you're going to get the result you're looking for. Otherwise, you don't. It doesn't work. But the good thing is if you put the right resonance in the frequency and it ignites right, then it goes with the same frequency of the quartz itself, which is very difficult to do. Then it won't blow up on you. It'll just start, radiating power. That's extremely difficult to do. So we don't have the right hardware to do it because our frequency is way too high in what we're using. You got to get it down to the hertz level. So, yeah. But, yeah, I know. Engineering, man. It's still engineering, though. I mean, when you really think about it, the principles are all there. You use an anode cathode effect. You're putting in heat to it. You're changing frequency to it. A lot of this stuff, man, if you do frequency for high voltage tuning, it teaches you a lot of skills to do that, man. If you can get that thing to light up, it's not like you go to your drill press and you put it on there. You know what I mean? You take your bit to it. Of course, it'll light up. You know what I mean? That's what it does because all the, vibration that's going on in there. I've seen those all day long and I've done those. But lighting it up with voltage is one of the first times I've ever seen it. So, yeah, it was cool, man. So I don't know what results. Yeah, I don't know either. Honestly, I think what everybody's trying to get to, and this is my personal opinion, is if you take quartz down to the hertz level where it was built, you'll get it to light up. And the trick is to understand it on its level. So if you put a piezo buzzer like we looked at earlier on mic stuff, and you stick it right to the side of a flat surface of it, and again, it's only one side of it because you're going to have multiple frequencies in there. You can get one of the frequencies that'll start to move the quartz. So it'll start to shake the quartz if you hit it at the right frequency. It'll start to vibrate a little bit. The problem is in all of this stuff is as you cut the next side, you got another frequency. Then you cut the next side, you got another frequency. That's one of the problems with quartz. There are multiple frequencies. They're like a little lock. You got to hit all the frequencies. And you don't necessarily have to have a piezo next to it. You just have to hit the frequencies. But then you got to get the stuff acceptable to the frequency going into it. So with a lot of quartz, you may have to put them in as a water to get the field to go into it properly. A lot of people don't realize that. Anything that shows up in water that has a frequency to it, you can use water as a medium to put your voltage into it. So that's just kind of one of those things, you know what I mean, you learn throughout doing this stuff. Some of it, it's just frequency based. If you hit the right frequency dead on, you have it. So I think it's honestly one of the future power sources that we have on our planet is understanding it properly because it doesn't just turn on, it oscillates. And as you get two frequencies bouncing back and forth in one of those things, you get a nice oscillation out of it. You get the thing to vibrate, and then you get it to light up on its own. You're getting power. I mean, that's kind of one of the reasons to do it. Now, it only lasts like a battery over a certain amount of time, right? You're fighting time on that one. There's only so much time it's going to last, but it is a hard surface and it will last quite a bit longer than a battery, that's for sure. So, yeah, there's some things to look out for in there. A lot of everything that you see in this, guys, if you put things in the correct frequency and correct resonance, God, they work so much better. So much better. You wouldn't even believe. There's so much pressure on these systems that shouldn't be there, noise. You can call it anything you want. It shouldn't be there. As soon as you eliminate it, man, everything runs smoother, faster. That's why we were talking about the spark gap with the Renegade, with the two types. You get the type that Mike uses, so we can follow the, his and what he did, and create the same thing. And then we try to create a RAV in it instead of the spark gap. I don't know, because it pulses. If it doesn't pulse fast enough, it won't build. But if I'm correct in the way it should act like an AC slush and going back and forth, which will create the RAV, which will create the cooling effect of the RAV, because the anode and cathode are cool to the touch as soon as you turn the thing off. There's not a lot of heat buildup there. That's the point. So that right there takes a lot of noise out of your system, and it makes it run so much smoother. I can't tell you, some of these bipolar Tesla coils, you'll just blow them offsets like crazy if you don't do it, and you put too much on the load. But as soon as it creates a RAV, load's gone. Load's gone. The noise is gone. All of it just goes away. That's the beauty of the RAV. However you use it. I mean, you can use it for that purpose. I won't lie to you. It'll probably work great. But you can also use it to see how plasma physics is done in open air. That's the important part. So I went on there. I challenged ChatGPT. Okay. So number one, Dennis, you would have won this argument I had with it. I said, show me the donut shape in open air plasma, because I've never seen it. Now, don't get me wrong. You can get smoke. You can get air effects. Plasma is not one of them you get as a donut in nature as a reality anywhere. Okay. It does not exist until I saw it today. So you would have won that argument. They couldn't do it. They kept showing me in vacuuming chambers. They give me writing. I said, I don't want any of that. I want a picture of it somewhere that somebody did. So Dennis, you got me on that one. Other than that, man, I've never seen it. So, and it could be out there, but I challenged that machine to give me all it got, and kept arguing with me to give me gibberish. I kept giving it back to it. I like to verify things, guys. I'm sure you probably know that by now. I want to see it done. Okay. If you're going to tell me about it, don't tell me all your theories. You tell me what you see. Okay. That's what I want to know. So, yeah, because the donuts are not natural. There has to be pressure. And what you'll see is when you bring up that picture again, you'll see the pressure you're creating in the zone that it was built in. That's why it did it. Without that pressure in there, that environmental pressure that it was created based on where it was sitting, it would have never done it. And that was the point I was making to ChatGPT when I talked to it, is you do realize that's, the environmental condition that it places upon something makes the donut. And it's an unnatural position for it. It's normally a sphere, or what I would call an orange effect. When you peel your orange and you see how it looks on the inside, how it looks like you could flatten that into a donut, how it comes up and around, but it's not exactly a sphere. Okay, but it is like coming in at the top a little bit. It's just like our Earth. Okay, that what I would have accepted if they said that was a donut shaped like that, even though it's a little awkward for a donut. But sure, not the way they make them in a lab. That's all forced pressure from magnetism. And what it actually should tell you, okay, in some of this, is the magnets are having an effect on how the field builds and where it builds at. So just understand that you don't need a magnet to create a magnetic effect. You can use air to create a magnetic effect. You just have to know how to do it. So when you get to open air and you want to create, say, a plasma ball or something in open air, you need to remember there has to be a magnetic field present. You know, any kind of eddy current, magnetic field, something like that, you got to have something to twist it. And as soon as you get something to twist it, it'll form. Sean was showing that in one of his experiments. He had the magnet in there and he started the RAV. And if the magnetic field was going the correct direction, then it created the RAV very quickly, extremely fast. But then you put it in the opposite direction, it wouldn't start at all. So it also was throwing out those, remember the ghost worm Joe was talking about? Every time it threw out the ghost worm, you knew that you had something in plasma physics because it's a plasmoid ejection that was what that was. So, yeah, I mean, if you learn how to do this stuff, like we took Tesla coils and I put a magnetic field in the air just about, what is it? Like a week ago, we were on Tesla. I was on Tesla Tech doing a live demonstration. I coupled those fields of those Tesla coils. I put 4 of them together in a square formation and then coupled the energy between them as capacitance in the air. So what it did is it took my ZVS driver that usually won't start until there's 5 volts and allowed me to drop it to 3 volts and keep it running. Guys, it's not supposed to run at 3 volts. You should not have that thing running at 3 volts. It's against the laws of the MOSFET going on in there. So what happened? Well, the capacitance came back to the ZVS driver and back into the capacitors and filled them, kind of like it was a snubber circuit in open air going back to it. So it was allowing it to operate in a non-operable position because of the coupling of the fields. That's what happens, and most people don't understand it. They talk about, I need 1,000,000 volts to lift something in air. They don't. You need field coupling. You need the air and the environment to pull in the energy because you've got to remember, you don't create or destroy energy. You only use it, which means energy is everywhere. And you're only pulling it in with the most effective trap you can. That's it. That's one of the rules that they try to tell you, but don't tell you, and they should tell you. You only pull it in from the environment. So far, we make a pretty terrible trap. But then again, we're not even trying. I mean, you got to remember this. We're using the cheapest option possible. Think about it like this. Everything is there to fill a capacitor, right? Fill a battery, fill a capacitor. It's just how fast you could charge it or how fast you could fill it. But it doesn't mean you can't use alternative methods. See, they say, put it in, spinning a magnet against aluminum and copper is a very weak field. To you and I, maybe, and to a magnet, maybe, but not to nature, not to the capacitor. The capacitor feels either way. You see, now you get into the understanding. You go, okay, so what else can I use? You go, oh, well, maybe, I don't know, let's just find another metal out there. Let's put brass in there. What is the field of brass when it does it? Again, does not have to be magnetic. As a matter of fact, the less eddy current, the better. So it's how fast the capacitor fills up. What about cobalt? What if you put cobalt in there as a metal? You see, these are the experiments we need to run. Whichever one fills up the capacitor the fastest means it is pulling in more energy from the environment the fastest, means it's filling up the capacitor fastest, which means we're in the wrong field every time we run magnets and steel. Just for what it is, okay? That's just it. We think of energy the wrong way. We think of it as the magnetic field. The world sees it as how much energy fills a capacitor. Then you start looking at all the minerals on the planet and you say, well, the energy is going right through this area of cobalt. It's going through this area of gold. It's going through this area of silver. By the time you're done running down the list of all the minerals that'll go through that'll have any kind of value, and the ones that are semiconductive that can be superconductive if you can saturate them high enough, which the amount of power in the earth you can, now you got to calculate all those, okay? So you put them all in there and you say, How come I can't figure out anti-gravity with a magnet? Because there's probably 1,000 different fields that you did not understand when you did it. That's why magnets don't float. You can't throw one out in the air and let it float. It won't work. Why? Because there's too many different types of fields and you're having no interaction with them. So how do you interact with a field that you cannot control how many things go in there? Because you're not going to create them all as power sources, that's for sure. It comes down to a simple understanding of high voltage leaching. Can you, on the back end, change something? Can you change the frequency of something that on the back end of it? Now think about this. And high society should know this already, and you probably do. When they do the horns and stuff, they do frequencies, guys. They're putting frequency in the air. They're not trying to couple the entire earth. That's insane. They're finding a localized environment, which is like a bowl. They'll blow all their horns into it, and it'll cause resonance inside the bowl. What does that do for the item in the bowl? Well, it doesn't have to pick up the energy from all the things that already has them in it. It simply controls them. Think about what I said. We're controlling on the back end. We're not controlling on the front when you first put it in. We're not controlling in the middle. We're controlling on the back end. The energy's already created all around us. Now we need to control it. That's what you must do. But if you don't understand the learning and understanding of high voltage leaching, it's going to be very difficult for you to understand. That's where you learn to change energy on the back end of something. It's, field shaping. It's field coupling. You're literally going to couple a field that draws in the environmental energy around it into those fields themselves. They go in a directional pattern. And no, they don't just go, back and forth to each other like this, like people think. You know what I mean? Like this? No, they don't. One this way, one this way, one this way. They're turning every which way as they go around it. Okay? That's why it works differently than most people think. But then every time it compresses more energy, those fields move faster. So they break the swinger limit in order to get it done. That's the point. You have to understand coupling in open air. That's why I do the Tesla coil experiments with the coupling so you could see it. You go, there's no natural way you should run at 3 volts when the MOSFET is at 5 volts that it must start. How did you do it? Well, I used field coupling. I coupled the fields between every single Tesla coil that was there and ran it back to the driving coil. It's exactly how I pulled it off. Now that you understand that, you got a couple things in the air. Well, how do you do that? Well, you need to understand spin and what you have to do to put things on this plate to make them spin. Once they spin on the plates, like the gravity flyer, they spin on the small plates, right? And you got a magnetic field going on the bottom. You got a high voltage field going on the top. They're held in by an impulse of your Tesla coil, which is the inside center of the Tesla coil. It holds in the energy because it builds cold plasma as it gets faster. I don't think a lot of people realize that. They just go with the outside of the Tesla coil and listen to ChatGPT, which tells you lies about it. It's an impulse that holds it in. So when you do something like that, it allows you to build up energy faster, and they start going faster and faster and faster around. And then the outside environmental energy wants to be part of the capacitance inside of it. So it'll start coupling with it. And then boom, you get this thing rolling, man. And then, there ain't no stopping it once you do. You mean, well, there's stopping it, I should say. But as far as amount of energy you want to pick up, it's all there for you to take it, is what I mean. You can stop it by stopping the machine, but I just mean the environmental energy is everywhere, and it'll continue to give it to you. It won't stop. Bernie, let's see. I can't add you to the stage, and I don't know why. So hold on.
Hey,
There we are.
there you go.
We are.
Woo. Yeah. We sent your son home halfway up because I'm proud of him. He made it halfway. It's more than I was expecting. Huh.
Oh, you
But
guys got up
then,
halfway, huh?
yeah, he did. So good on
Nice.
him. I just got to the road part, the cheat, because it was straight up before then. We got a nice view. And I'm gonna jog up the last bit. That monatomic gold, I tell you, does good for the body.
Huh. Well, don't leave him behind, Bernie. Make sure he goes with you.
No. We made. I went down with him. Made sure he's back on the road. He should be coming in your door any minute now.
Nice.
I never leave a man behind. Never. Oh yeah. There we are. There's the lake. Beautiful lake. And we are getting to the summit with the crosses again. Told you I'd make it up before you done the stream.
Look at that sun, Bernie. That sun looks like the rav we create, doesn't it?
It does. It really does.
That's
I
crazy.
don't want to see it ravaging that lake. That'd be kind of scary. All right. We got the full 360 degree. We're on top view.
Nice, you made it.
Gonna rename this one Bernie's Mountain. Mount Bernie.
Nice.
There we go. Take the view so nice it takes the breath away. No, that's just climbing the mountain. That's okay. Good exercise. And right there, Nathan. That's how I sneak into the lake country. Yeah. Down that hill. I go for a swim. I think the sun's too low today, so I'll probably just come back home.
Yeah, you can't swim in that lake.
I guess so. I guess I need to find a nice lady with a boat and go
Yeah, there
boating.
you go. There you go.
All right. Well, I figured I'd follow through with my word and show y'all from the top view. The view's what makes it worth it every time. In California. All right, we'll see you in an hour. What's up, my friend?
Right on, man. Yeah, we got those in the backyard. Got a lot of moles in the backyard. Then we get chipmunks in the backyard. All that stuff, man. I go over there and I feed them sometimes with peanuts, stuff like that. Huh. Oh man. Yeah. Well, hopefully they stay out of the way. Yeah, that should be good. Yeah, but DCAC. I don't want to explain this. It all depends on the coil you build, and when you do double coils, and then you put a third field next to it, you change it. So say you put one Tesla coil in, and you put another one inside of it, just number 2 coils, right? Run them with a DC flyback, and then turn on a Tesla coil next to them. It'll change the energy to an AC. That doesn't sound right, but it's absolutely perfect to work. So, that's high voltage because it's open air and it's coupling with the field in the air, changing the frequency of it. So, yeah, you're fine to do that. Do it with an AC flyback. It works as well. Joe, what's up, brother? Yeah, you just got to change it as soon as the energy gets to the air, you can manipulate it. So the tuning afterward is usually high voltage. That's why I say high voltage leaching. Anytime it gets open to the air environment and create a spark, you can now tune that voltage from the backside of it. So think about your environment. All the energy is in the air. We're in an open air capacitor. So all the energy is already in the air and it's so saturated that we're not going anywhere, right? So when you think about it that way, all you got to do is put in the frequencies in order to couple it. Well, it's which fields are you coupling and where are the frequencies at? That's the main goal at that point. And then your whatever device you're using has to be open to the air to couple it and stronger than the field around you. So they always say that the Earth's gravity is weakest compared to an EM field, right? Okay. Use that to your advantage then. Now you can couple the fields because your field is technically stronger. Now that all falls apart when you get to the core of the Earth. You're not stronger than the core of the Earth. And the fact that we're talking about gravity as far as the outside portion of the field instead of the inside portion of the field makes it absolutely like an absurd conversation to say that a magnet's stronger than the field, of gravity, because gravity goes around the entire planet and the magnet's just basically in your hand. That makes it a ridiculous argument. But in the field that we're in and the position in the field that we're in and the locality makes all the sense in the world. So, yeah, AC is just basically a slosh. It's taking a DC and sloshing it back and forth. Think about that. That's all you're doing. So when you run like my Utron coil, right? And I've changed where I put the number 1 coil on it, I turn it right to AC. It'll slosh easily. You put a load on it. So as soon as you put a load on it, it's like you build a RAV or something like that. As it goes to the frequency, it'll start sloshing the coil like this. The energy goes back and forth. And you'll start getting the AC sine wave in it. So you'll get a normal wave like this on your oscilloscope. Then you'll get that little AC sine wave that blows up inside of it, right? That's an AC signal all day long. So it'll create it. It's all about the slosh you do it. So to think about an AC flyback. What is it? It's just a wound coil, right? But when you put a load on it, it puts the energy in a position where it has to slosh back and forth in that magnetic field. That's why it's called an AC flyback, because it goes in there and it produces an AC signal. DC can't do that because it goes through what's, the diodes and stuff that are inside of it, which are just the wraps, as we saw before. It can't get back to slosh. So that's why you use an AC. That's why you use a Tesla coil. Yeah, it's just oscillating, goes back and forth. It's fairly easy to do. Once you understand the principle of it, you just got to put yourself in a position to do it. So, but that's again why the two number 2 coils work together with the field on the outside, because it's creating a situation where it's sloshing back and forth. And it'll take all the frequencies and align them together. Now you may be off by like 5 kilohertz or 4 kilohertz or something like that, but the fields will align because they're creating layers, sheath zones, because that's how high voltage and plasma structures. They structure sheath zones naturally in a spherical form. They don't make donuts. Not in a natural form, they don't. You have to compress in some way to get a donut. So I wish I had a donut right now, to be honest with you. A real one. That'd be nice. Anyway. Yeah. What's going on, brother? Yeah, I'll be honest with you. It's not terribly difficult to do, but it's getting someone to understand it is fairly difficult, because you're putting in so little power and it has so much power into it. They didn't realize that a generator was a trap for energy. They think they're producing energy, even though they tell themselves, you know what I mean? You cannot create or destroy energy. And they say it all the time. But then they think a generator creates energy. Try to get that one through your head. How does it create energy then? If it's basically there all the time. You don't. See, that's the problem they run up against. It doesn't. That's when you understand the energy law better, because they originally knew you were pulling it out of the air. Yeah. Fun stuff, huh? Things that they should have just told you in a very clear way instead of, I don't know if you guys get frustrated with this. Every time I watch one of these physics shows, I feel like a toddler. I feel like, okay, put me in the corner with my cookie and my milk, and then you could teach me something so important. And it's like, oh my God, dude, seriously? Like, or they're so slow and they're all about the math and I just want to cry. Like, literally a grown man of my age wants to cry watching you because you're so goddamn boring. Like, God, I just want to pull all the rest of my hair out. Look, it's already receding pretty bad. I just want to pull the rest out. Like, dude, I tried one day. Oh God, I did try. I got a bunch of coffee, right? And I said, you get the strongest coffee I can. I'm gonna go to Starbucks, give me some nasty, strong, dirty tasting, tastes like nasty dirt and toilet water is what that stuff tastes like. And I drinking it and trying to watch physics videos, and I swear to God, I would go over there and I couldn't keep my eyes open, and I just opened them like this, you know what I mean? Like, oh my God, I gotta see this. You know what I mean? And I'm just dying. And then I turn around and the next thing they're treating me like a toddler. In the end, I didn't get all the information out of it. I had to watch another video because all the good information they left out of it. Oh, here's the basics, which gets you out absolutely nowhere and gets you in trouble and understanding something wrong. But here you go, little toddler. Here's what they are. Yeah. Old man ain't playing that game, brother. Don't start that garbage with me. Oh, I hate that. Dude, seriously. Like, I was thinking maybe toothpicks to keep my eyelids open or something. You know what I mean? I mean, I don't know. I drank enough coffee to keep me up for like 4 days, and I couldn't stay awake watching this stuff. It was bad, man. And then when you get over there and they go, oh my God, we had a fraction. And then on the other side of the equal sides, we had to put an additional fraction over there just so we could flip it upside down so that they can counter each other and remove themselves from the equation. And you're going, was there a reason for the other one? Because the math formula is based on everything that's in the experiment, not on something that you pull out of your ass, right? No, there wasn't. It was just something they pulled out of their ass to make the math work. And you're going, well, without any fundamental reasoning to do that, it's bad. You should never do it, ever. That's why math proves things. All you're doing is proving that math sucks that you use. That's not good. That's not good for anybody. You can't do that. You got to keep it how it's written. That's why, you know what I mean? When you get those long formulas in algebra and you don't get as clear x equals this, then that's what it is. Even if it's, like a bunch of gibberish on the other side. Yeah. Anyway, I'm just grumpy old man, dude. Be honest with you. Some of this stuff frustrates me because I do it. I build the stuff and I'm looking at it going, you can't do that. You can't build it that way. You know what I mean? And they tell you, oh, yeah, it says math-wise I can. No, you can't. Because what you thought was a negative wasn't a negative at all. It went right on you or left on you. It didn't go the opposite direction. It went, counter to it. Or, they always talk about, oh, my God, you got to have the right-hand rule, right? But they forget this one. They go with these. It's like, let me run a system and let me tell you about T1 and T2, right? In time. Okay. What created the curve? It's a straight line between 2 points until you create a curve. So where's the third vector? I saw T1 and T2. Where is T3, T4, T5, any of the other ones? My 3D printer doesn't make 2 points. It makes 200 points to get to the other point because it gives it a direction around it. Not to them. Everything's on a flat surface to them. They say, oh, it's got a Z. It's got a Z. Do you use the Z? Just saying. Do you? Because if you don't, it's useless to have it. I mean, it's kind of a requirement in order to be in 3D to use 3 dimensions, not 2. Anyway, my frustrations aside, I argue with a lot of things. You probably already know that. Whatever. It's part of being old. That's all you do now is argue. Get tired of hearing the same crap that doesn't work. I don't know about you. How many times have you heard like a billion things about every single one of these motors and stuff that we build, and they're all absolutely fucking wrong? I mean, I don't know about you, but I'm getting sick of it, to be honest with you. I mean, how many of them are just asinine backwards? Like, Bedini says, don't use neodymium magnets. He must have said it 100 times in every one of his videos. You turn around, what does everybody do? I've got to get the neodymium magnet. He just told you, dumbass, not to use it, and you just did it anyway. Yeah, Stuff like that, man. It's like frustrating. You know what I mean? If the original maker tells you to do it his way, do it his way first. Then you can decide if you want to change it. But don't go around changing stuff first. Oh, let's see right here. Were you planning to make an Oma build Bedini schematic? I will give you the STLs. I will give you the cut list, as well as the schematic for the transistors and everything. Absolutely, along with how to wind the coil and everything else. All of it's on video, so you'll get it all when I do the build video on that one. Once I get it up and running, you'll absolutely have everything. So, yeah, everything that I saw in there that I could figure out, I put on it, just like he did. So, absolutely, you'll have all of it. Yeah, no messing around, man. It was, what was it? 12 inches by 4 feet was the board you can use and create all the parts, and that's exactly what I did. It was in his, oh man, somebody did a PDF of it, and it showed you exactly what you needed. And I went out and I got myself a little mini table saw, ran it on there, and got all the parts. About the wheel, the aluminum one, not the steel one that they try to sell you in some kits. He said aluminum, so I got aluminum. He said get the magnets and put them in, you know what I mean, based on the spokes. Did that. Tape on the outside, make sure you glue it on the inside, did all that. Wound the coil. I think my bobbin's too high on mine, so I'll be running with it, probably too big of a field inside or too far away. It may actually help me because it won't build up so much, but I was probably about an inch off. But this is one they said to use. But there's no way that he wound double the wire on there because what is it? 140 feet is what I wound, and that was my front yard to my backyard. It was quite a long distance to wind that. And I saw the distance he wound it. I was about the same distance, so my bobbin had to be off on the one that I used. So I'll show that as well. You know, not afraid to show the failure in it. But yeah, you get the STL files, everything, man, and I'll, you know, size the block for you for the aluminum and everything. And I'll have to figure out exactly which drill bit I use because it works really easy. You don't even have to tap the aluminum. You just have to put in the what is it? M3s is what I think I used in there, metric threes, and basically they self tap under the aluminum, so it works out real good because it's soft metal. Um, yeah, and both sides of the thing are the exact same. You can take the other side and put a little saying or whatever you want in your 3D print. I mean, it's up to you. I just put a blank in there in mine, but yeah, you'll get all that stuff. So yeah, not a problem there. Um, yeah, that I have little things at the top. I'm gonna have to 3D print parts for plugs because it uses a rod that goes across, like I was bitching about earlier. So I'll have to create a plug there. But you know, you can always just make the hole smaller. That's I thought there was going to be a bearing in there. There wasn't. They showed an open top that looked kind of janky. I didn't want to do that, so I rounded the top. So yeah, go back to old wood shop days, huh? You strap the two pieces together, you sand them together, and you round them together. You know what I mean? Draw the round in there. We're using pine, so it's fairly easy. Throw on some 80 grit, and then just round it to the line. You know what I mean? Make sure they're together so it's exactly the same on both of them. Yeah, old school, man. That was pretty easy. Make sure that you know what I mean, you drill in and put on the top part before you hook in the bottom so that you're not sitting there with the screwdriver trying to crank it and put a screw up like this in there. Yeah, don't do that. Oh, a lot of things, man. Go back to the old building stuff days. But yeah, I'll give you that one. And then when I'm done with the pulse motor as well with Mike's Renegade, I'll put out one for that one too. So you'll have that one, the other one. They'll come with the video. And then I'll release the STL files for everybody. And then the end machine. Once I figure that one out, you'll have all those as well. So if you guys follow along the projects, you know, I probably should update the Tesla coil one for everybody, put it all in one good video for you. Do a nice clean job of that. But you'll have 4 different items that you could build to check out every theory that you got. You know what I mean? So yeah, I mean, I've been playing this stuff for a while, guys. And I bought a fish tank. I told you guys a while back I had an idea for high voltage in a fish tank. So I bought one right over here. I got an acrylic fish tank. Okay. And I plan to put in an AC flyback setup, I'm going to put high voltage at the top and I'm going to put a magnetic field at the bottom. Okay. And what I'm trying to do, probably a DC might be working better, but I don't think I can get the voltage high enough. So I'm going to have to use an AC and just change it a little bit. But I want to create lightning. So if I can get it to just give me the open field. So for those of you who've done high voltage before, you know how it works. You get like a saw blade over here, and then you get yourself a shaft over on this side, right? And then every time it points like this, you're going to get ion wind that comes off of it like that, right? When you put them too close together, you hear a high voltage hiss, and it'll go. But when you pull them apart, you get basically the field that we're in now, which is too far apart to do anything. This is what T.T. Brown was working in, right? That's exactly what I want to create, is that field that's too far apart to get any spikes or anything to go over. My idea is simple. If we temperature control it, we put water in the bottom and we put dirt. So, you got a water table that goes to, then you have dirt over the top. In some portions, you have salt in there. So there's salt pockets in there. It should actually give me a field where there is grounding capable inside of it. In order to put anything in there, I could put an antenna in there and get it to spike. You know what I mean? Just like an antenna would to a big building. We can create that. We can then move it down a little bit, put a capacitor in between as we collect the energy in between it and show that we're filling capacitors out of it, just like you would do if you put a Wardenclyffe tower in the center of there. It'll give us that ability to do it. Because it's temperature controlled, it may or may not, and I'm hoping for the may part, I want to create rain clouds in there. If it's the same effect and we create the same condition, can we get rain clouds? I mean, why not? I mean, if we can pressurize it, and I'm not talking a lot, not a tremendous amount of pressure at all, just a little bit. Just put a little bit of pressure on it. Make sure we put the minerals in the ground. You know what I mean? So this isn't super specific to super water or different kinds. It's put regular water in there from the tap. Drop some salt in certain spots so that it builds up in a salt area. Okay. Put regular water in the other. Make sure that it doesn't interact with the salt. And I don't know how I'm going to do that yet. But they should create a barrier between the two if the salt's thick enough in the water. And then see if we get some clouds, man. If we get some clouds, we get some, any kind of the high voltage, hitting down on anything. We can test how the pyramid works as a capacitor. We can, build something, put it in there, that looks like a pyramid, maybe pressure inside of it. And then just, take the rock and make sure it gets to a water source and let it fill up like a candle wick. And then we can either prove or disprove how the pyramid is a capacitor. I think that's absolutely amazing. Being that it's not too far off to do. I mean, if you think about it, the high voltage and how easy it was to set it up, we're just looking at distance control on how far apart we need to do. So some tests on that, how we separate the plastics and stuff. I mean, the environmental control has to be there because it can't just be a sweaty box. You know what I mean? You got to be able to keep dry air in there as well as moisture when you want to put it in there, so that you can control if it gets like moisture for the high voltage get in there. I think that's the way to go. Like I said, I got a big fish tank now sitting in here, but I got the acrylic one because I didn't want to use glass and have any problems with that. I want to be able to drill into the side of this thing, or take a hot poker to the side and get in there so I can hook up all the tubing. But considering we know how to do this already, you know what I mean? We can create heat. I'm sure you guys seen on the internet, you can make your own little air conditioner. And for this little area, it's not that difficult. It's very small. We don't need something super special. And then we can control the heat level in it. We already know how to do that with our induction coils from our ZVSs. We can control the heat. Yeah, no fish. No fish in there. No fish fry. Oh, man. Yeah. It's, let's see, it was about 3 feet long, about 15 inches deep, 16 inches deep. and it's close to 2 feet high. So that should give me some distance for some dirt in the bottom and other things, and then some high voltage stuff in there. But yeah, it's on my list, man. So as soon as I finish these 3 builds out, that's the next one I'm starting on. And I'm excited to do it because I've been playing with high voltage for a long time, and I always wanted to see what would happen if you put something in between it, but put earth in there and high voltage fields and water and stuff. So kind of a cool experiment, man. That'll be one that's just out of sight, man. If it works, I'm praying it works. I'd like to see lightning, man. In some form or another, and you never know, man. If you can get the energy where it's like a screwdriver in the middle of a high voltage field, you could do anything you want. You know what I mean? You could just put metal on the ground and it'll do it. Turn down the energy a little bit. Should be just back it off a little. Then see what happens. Yeah, I can make a little mini Wardenclyffe in there too. You see, that's kind of the point, though, isn't it? So if we can prove out the system works in the way that I think it works, then we can build them as big as we want. Then you can really get some good, information and stuff. Maybe a university will pick it up and want to do it. You know what I mean? Just to show how the experiments work as well. That'd be awesome. But yeah, if we can get something to proven concept, I think it's worthwhile. So that's why I bought it. It was on deal, man. It only cost me $80, so I'm pretty happy about that. Got the high voltage equipment already, so pretty happy about that. So yeah, we're gonna get there, man. So I gotta get as soon as Joe's ready, man, and does the interview for the Rav thing, just so we go back to that real quick. That video is gonna be awesome. It's pretty much Sean's how do I want to say it? All of his early videos, so it's gonna be like a 20 or 30 episode series for the first year, based on all the videos that he got and made already and things that he did. So it encompasses how to build the Rav and stuff like that. What the first thought of it, how he first did everything in the live stream. It encompasses all of that. So after the first video, you know what I mean? We'll continue down that line and go with the next couple of projects that he worked on. You know what I mean? I think by the 3rd video, we should be into the vacuum on how he did those experiments. I remember the angel Rav he did. And then we'll have put in there in one episode, Joe and I did our own Ravs and our own experimentation on it. We'll show that. We'll show all the lighting effects and exactly from front to back how they worked in one episode. I think that's going to be amazing. We're going to tie it into the stars and universe and stuff and see how much the plasma actually looks like things in the universe. You know what I mean? Maybe they match up, maybe they don't. Maybe the fields match up, maybe they don't. We'll try to get them as close as we can and compare them and leave it up to everybody else to decide yes or no. It may work out that they look like common things that we see all the time. You know what I mean? So we always leave the open question, you know what I mean, of what it is. So nobody's out there thinking we're trying to lay down the law on anything. We're just trying to show it off. So that was it, man. I'm really excited about that because I kind of like doing it, man. It was nice. I got different camera angles and stuff, and you get to see different parts of my my like little studio that I built out here. So I think it's pretty sweet. But yeah, we got some good stuff going, guys. I'm almost done with that Benini. Like I said, if I didn't take off to do the rap video, I would have already been done with it and had it running. But I wanted to make the rap video because I have to pull in information from Sean and Joe together to get it. So it takes a while. When I have it, it's easier just to put it all together. So yeah, it should be pretty sweet, man. Should be pretty sweet. You know what? I think today, let me see if I can't pull it. I will actually end instead of my normal video. I'll just put on the test video here for you guys, so you guys can see the rap video on the way out. You know what I mean? So I think that would be pretty cool. Let me clear some of this stuff off of here. There we go. Let's share it. Yeah, make it bigger. All right, guys. I want to thank everybody for watching today, man. Have a great night. Sean, love you, brother. This is pretty cool, man. This is for you guys, man. Have a great night, guys.